Hello, I'm recording again. This is going to be Quest 3 of Story 2. The first two quests, well, the first quest actually took me almost 2 hours because I made a mistake with a Golang library I was using that just ate up time because I was just getting completely wrong answers. The second quest took me about an hour. I seem to remember that from Story 1, each quest took me about an hour. Now, I have less than an hour to record this in, so I hope I will finish the third quest, but I may have to pause at some point and then come back to this many hours later. We'll see. It's a little bit dangerous recording it right now. Dangerous schedule-wise, not like actual danger. But we'll see what happens. So anyway, this is Everybody Codes Story 2, Quest 3. And let's see what happens. Okay, and before I opened this, I should have set up my basic Quest 3 framework. So let me go back and do that, and yeah, I'll eat the time. So I'm making Story 3. And actually, wait, I'm not making Story 3. I'm all done with, I'm not doing Story 3 yet. So I'm in Story 2. Yes, and in Golang of Story 2, and I'm going to make the Quest 3 directory, and then over here, let me just shrink over here, I'm going to grab a little bit of the top of my main.go and turn it into a new file here, main.go, and this is Story 3, Quest 3, Part 1. Okay, I should have done all that before I opened Quest 3. Okay. Some inventions are born out of necessity, some inventions are the result of sheer brilliance, and well, a few others are just born. Rollable die, not the usual cube. Cube. My creation. Finally cut. Angular log. Trust what it shows. No. Just a fair roll. Okay, my version of the die can have any number of faces with any values, even negative ones, and the rolling die must return a random result. On the other hand, the ability to predict the next results, fully determines its subsequent rolls, even though they appear to be random. So you have faces and you have a seed. The first number indicates the ID. Second param is a list of the faces. Possible seed parameter, which is used by the algorithm to go. Each die also has an inner pulse and counter of rolls used by the algorithm. First, initialize the inner pulse die with the seed parameter. For each roll, calculate how many faces the die has to spin to. Spin equals roll number times pulse. For the first roll, we start from the first face from the faces list. Roll number starts at 1 as it incremented each time the die is rolled. Now you know the next result rolled with the die. pulse by the seed parameter and set the remainder as the new pulse. Increment the pulse by 1 and add the roll number and seed parameter to it. Increment the roll number and go back to the second step for the next roll. Okay, so start with the pulse of 3. Then for roll number 1, we do 1 spin. Okay. Then pulse becomes pulse plus spin. Okay, spin is roll number times pulse. Pulse plus spin percent seed, so that will give 0, and then we would say 0 plus 1 plus roll number plus seed gives you 5. Okay, now what I don't understand okay, so I guess I don't quite understand where result comes from. I think that the result is just the index here into faces of spin, modulo, how long the faces list is. So here, let me check when spin is 10. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so clearly it's not that. Is it the number of additional things we roll after the previous roll? Yes, okay. For the first roll, we start from the first face, and the faces list. For the next roll, we start from the previously rolled face. Okay. Simulate consecutive rolls of all the dice simultaneously and add the number of rolled digits as your points. Goal is to reach a total of 1,000 points. Okay, now by add the number of rolled digits, they mean add the value. They don't mean like, I assume. Yeah, they mean add the value. They don't mean like take the individual digits and add them together. The total number of points is reached after okay. I'm not looking forward to trying to finish all 3 parts in an hour. But, first of all, let's move everything over to input. Now, okay, so they're going to look like that. Okay, so what do I need to keep track of with the dice? With the dice we have I need the seed and the pulses and the faces. It's been a while. Type. Okay, here. Struct. Pulse int seed int faces int. Okay. Dice make die 0. I don't know. Now, wow. For scanner.scan. Parser regex dot must compile. Okay. So we have \d plus. Okay, \d plus colon spaces equals d comma plus okay. Now line parser dot find string submatch. Find string submatch. Scanner dot text. Value whoops, that's what that was. Find string submatch text. Okay, and then I say okay, and then I have 3 things here. So pulse. Okay, so seed. Actually, we're not going to do that. We're going to do dice is going to be map from int to die. Dice ID starconf dot parse int parse result. Wait. Yes. I submatch subbench 0 is the entire expression, so what I want is I want parse result 1. Parse int base 1032. If okay, then we're going to say seed parse int parse result 3 base 10 bit size 32. Okay, now what I want to do is I want to get faces. Strings dot split parse result 2 here's what I'm going to do. I'm going to face comma error equals starconv dot parse int face stir 1032 pad input and now I'm going to say for face error, then faces dot append, faces equals face append, faces append int face. Okay, and then dice bracket dice ID equals die of pulse seed faces. So pulse becomes int seed becomes int seed faces becomes faces. I need another one that is last IDX int, and last IDX does that say? If Skinner dot error no, what I want to do is I want to do just panic. What does that do? There, we'll just panic on that. Okay, so dice that's kind of the... Okay, now what I have to do is I have to okay, so what I'm going to do is I'm going to say func roll die die, which is a pointer to a die, and this is going to return an int. So let's copy these things. So pulse. Okay. So spin pulse times roll number. Okay, then result IDX, last IDX plus spin. Lang die.faces. Faces bracket. Okay. Return result. But first we have to update everything. Pulse plus spin. Roll number plus. Okay, now store everything. Now back. We have die dot pulse, pulse, die dot last IDX equals result IDX, die dot roll number, return result. Okay, so we have last IDX roll number, return result. So, let's just here, let's just do test die equals die of, what are we saying? ID is 1, seed is 3, so pulse colon 3, seed colon 3, faces, two, 4, -1, 5, 7, 9, and by that, of course, I mean and let's see, roll number is 1 and last IDX 0, roll number 1. Okay. For range, and I'm already half an hour in, so obviously I'm not doing all 3 parts here in an hour. Sorry. Okay, so what do we have here? Roll number, yeah, we have rolls up to 100. Test die dot roll number, spin and miss, and result I have, and pulse after roll. Okay, result, roll, test die, and then pulse. Let's just do a simple print line of roll, okay, I'm just gonna do that just to make sure I have everything correct. Okay. Okay, pulse after is 106. Okay, so I got the correct result for 100. Let's just check it for, I don't know, 30. 30, result 5, pulse after 34. Okay. Roll 50, result 2, pulse after 54. Okay, I feel good. I feel very good about this. Good. I feel good that I have that tested. Okay. Now, to be 100% sure, simulate consecutive rolls of all dice simultaneously. Add the number of rolled digits as your points. Okay. Now, I will want the roll number. Yeah. Okay. Rolls taken, 0 points total, 0, while 4 points total less than that number. Okay, so for, don't care about the ID, die in range dice. Points total plus equals roll die. If roll die and then rolls taken plus plus. Print line P1 rolls taken P1 PG okay. What? Oh. Range 1 with length 0. Okay, did I forget to do? Okay, let's look at that file. One. Okay, so that's my input file. If parse result 0 panic scanner dot text. Panic 2 faces is okay. Right. Okay, 527 is the answer, in theory. I'll go back and see what I did there in just a second. 527, submit. Nope. Answer is correct. Answer is incorrect. Okay, so let's take this. Copied. here. Okay, so we are going to, well, I am glad that I spent the time to, actually, hold on. Story 2, Quest 3, Part 1, SAMP. Points to exactly 1,000. Yeah, that's also not what they say happens. So, print line, DBG, rolls taken, have points total. Okay, so this is very unusual. Okay, so 10. Okay, roll number. Okay, so let's go here. Let's say okay. Okay, so they are always rolling as 2, 1, and 7. Oh. I'm copying. Yeah. Pointer die. Okay. And this is 844. Yes. Okay, so let's just try this here, and then I'll clean it up. 637. 637. Submit. Yay. Okay. Wow. Took way too long. Okay, so what I did wrong here was that I was making this a map to just straight up die instead of to pointers to dice, so that when I did a roll here, I was modifying the die that I'd gotten out of the map, and so then I either needed to shove the die back into the map, or I needed to get the original die. Yeah. Okay. That's, classic computer science mistake. one of the classic mistakes is referring to whether you're pointing at the actual object or at the thing. Yeah, data under the object or the thing pointing at the object. These dice, captivating games, racetrack, sequence of random numbers range 1 to 9. Race. Several players take part. Each player is a bat who will win the race. Each player has one of the dice prepared for the game. The players see the dice as identical. They only differ in seed value, of course, all the outcome of the race. Bets of the participants are perfectly balanced. Random numbers 1 to 9, matching the possible outcomes of a die roll in this game. Each player places their tokens in the first space of the track, starting from the left, and takes a roll of the die. Number of the space they're currently, they move to the winner is the first player who passes the last space on the track. Need to practice simulating. Predict the order in which the players will finish the race. Okay, so all players okay, but what is this number here? Okay. Oh, and layout, that's a track layout. Got it. So the track is not directly these spots. The track is like that. Okay, turn 1, die 1 yields a 5. Okay. Got it. Yes. So dice IDs. Okay, so we have the dice IDs. MV. Okay, so we have the dice IDs, then followed by a track number. Okay. So okay, so copy the input pulling part of this. Okay. So copy the input pulling part of this. I don't need that. Okay, part 2. Okay, so if text 0 else break. scan. Actually, let me just say, let me have the default. Then, right. I should, clean up for white space and stuff, but they don't put new lines at the end of their files, so I'm fine. Track stories 1, then we have yeah, okay, so what I want is I'm going to remove a thing when I don't need that. Yeah, I'm going to remove a die. Okay, so finishers make int 0 lang lang dice. Finishers that. I'm going to spell it correctly. Oh shoot. I thought I had a whole hour. I do not have a whole hour. I am going to have to go now. I will be back to this and start up, and hopefully the pause you won't even notice. And I'm back. So, not as smooth a transition as I want it to be. Okay, so what I'm doing now, make the finishers that order, and I'm going to then, okay, so we need to do this, and we have the players. The players are all so all of the die are players. So players make map int, and then for device ID, range dice, players bracket device dice ID equals 0. Okay, so for players greater than 0, okay, all players roll their dice once per turn. Dice will ensure no tires at the finish line of the race. Okay, good. For device ID die pointer, or dice ID die pointer in range of dice, okay, result equals roll Actually, no. I want to do this over players, because players is the thing that's going to get smaller. Die pointer. Result. If trackster bracket current equals 0 plus byte result, then we have on if current length of trackster delete players device ID or dice ID else players bracket dice ID. Okay. Length. Oh, and when this happens, when that happens, of course, we also do finishers dot finishers append okay, and then okay, now we're all done. Print P2 players bracket 0 players bracket 1 range now we do print here I meant to say finishers, and here I meant to say finishers. Okay, let us go on with this. Okay, let's okay, let's actually though, what if we copy that, file, save save as p2 samp. Save. Okay. Right. If false. $70. If false. I did not mean to change this file. Don't save. Okay, hold on. I want to change here. Quest 2. Undo. Discard file. Okay. Okay, so 1342. Okay, so I think I can trust this. Yay! Oh man. Lots of time, but oh well. Part 3. I have also come up with an idea for one where I walk away rather handsome. Maximum possible size of the prize pool. All square places. Take to add at least one coin to the pool. Assuming all places. Can then move. Okay, so I have to find more dice in all possible paths. So, what I have to do. So, first off, okay. Now, what I'm start does not match. Matches the space. Takes the coin from that space, adds it to the prize pool. Okay, so if I read the directions correctly, every initial roll is part of the okay. So okay, I'm gonna have to check something here. So first of all, I'll download, and I will move this. Hello? PowerShell, what's going on with you? Okay, I don't like that at all. Okay, what is going on with you? PowerShell, why does that what is up with that command? Okay. Okay. Why? Okay, anyway. Copied. Right. Now, I'm going to do file, save as, now what I'm going to do is copy this input arrangement I have here. And now what I want to do, is make sure here that in the sample, so here's my problem. According to the way that the directions are laid out, to the way that according to the text of the directions, if you had dice such that all of the possible input, all the digits 1 through 9 were covered by the initial roll of the dice, then all of those should be marked. So I'm going to find out for these 9 dice, what are the first rolls that they do? And then I want to make sure that whatever first rolls they do are covered here. So among other things, I have to check that 3, 5, 6, 1, 5, are not covered by initial rolls. Because otherwise, the rules are a little bit different than what they say here. So I don't trust my reading of the rules English, because I don't trust that the people who made the tool, made the puzzle, and myself are necessarily speaking English exactly the same. So, for die pointer, range, dice, result, roll, print line of okay, so they all did a 2 initially. Okay, and the 2s, the isolated 2s are part of this. Okay, so my interpretation of the rules and their interpretation of the rules seems to match up. Okay, so one way to do this is to start with all of the spots taken and then roll 1 dice until you can't take any more of the spots. And then you do the next dice, the next dice, the next dice, and yep, that I think is what we're going to do. Okay, so first off, let's finish scanning the rest of this. So for scanner.scan, this will be grid, make array of string, grid append grid scanner.text. Okay, then I guess I have to do covered. So covered, make map coord to bool. Coord doesn't exist because coord is the type I'm going to define up here. Type coord struct x int y int. x will be the first coordinate, so it'll actually be the row, but it doesn't really matter. Covered. Okay, so, and what I'm going to do first is I'm going to start with candidates. That's going to be a map coord to bool, and for x range length of covered, for y range length not covered here, length of grid, and then I just say candidates bracket coord true. Then for length of candidates, while the length of the candidates is greater than 0, actually I'm never going to use dice ID. Roll for I guess coord range candidates yeah, okay. New make map coord bool. If grid bracket coord dot x bracket coord dot y I know I don't have to do this because Go has separate namespaces for variables and types, but I just would feel weird reusing coord since it's a type name as a variable name. Equals 0 actually 0 plus byte roll if that it is true, then we first of all covered bracket C true, and new candidates, true, C1, C2, C3, C4, C1 is okay, so it's you can move in one of the four ways. You can move in one of the four ways. Right, up, left, up, or down. All right, okay. Two. Okay, then if all map C1 new candidates bracket C1 true. Okay. 3, 2, and this is a place where I really feel like I would, write a mini function or something. Okay, if that for C in range candidates there. Okay, and then we do that, and then we say candidates equals new candidates. Okay, and then we yeah, I could really yeah, there. Actually, wait, can I just do this? Candidates equals because if because I never touch candidates, and yeah, okay, that works. Okay, and then okay. Is this gonna work? I think it might. I honestly think it might. But I can check it by running the test code. Okay, that looks very promising. Okay. Okay, right, so that is looking good. And we are going to try it out here and see what works. Yay! Okay. Yeah, not a great time overall, but I had to pause for a bit in the middle, and I don't actually have a good sense of how long this took me. Maybe an hour and a half, maybe a little bit longer than that. Yeah, but that's the price I pay for not being able to just do this straight. Now, I feel like maybe I should print out the resulting design, because they have an interesting design here. So, okay, so how would we be able to print out the resulting design? Well, I think that we just go with this. Here, and let's do B3. And now to print out the resulting design, we'll do something like this and say if covered printf else yeah, so we'll print that. Print line at the end of every line, and okay, let's see if there's a let us see if there is a pretty picture for us waiting for us there. There might be, but we will never know. So then okay. View. Let's try to make this. Okay, so it's a Python logo, a Java logo in the middle, a C++ logo here, a there, everybody codes duck, PHP, JavaScript 101. I do not see a little gopher, gopher in here. But oh well, that's fine. Golang does not actually need to be represented properly. It should be, but it doesn't need to be. Okay. Well, that's that. I will. Oh, I guess I should push this up to. Temp.text. Note how Visual Studio Code marks it as. Git add West 3. Okay, let me remove the if falses. I really should fix up my standard boilerplate here so that these take arguments through flags that then I could pass or not pass, and I wouldn't have to comment stuff out when I want to use a different file name. Okay, let's just double check this. Yeah. Okay. Git commit -m. Okay. And I will see you next time. I am hoping to get to the, well, there's still another story to get to here. There's still story number 3. I'll get to that, obviously. And then there is also an event I haven't done yet. The 2025 event, the Song of Ducks and Dragons, which, as you can see, I haven't even started. So maybe I will be able to do that and do all of the problem solving while recorded.